Okay, now this is basically why we call it linear velocity, because you can imagine, I could get my string, but there's no way I'm going to be able to show it in this little space. If you put a pen on the end of a string and you turned it, right? If if at some point you stop turning and let it go, the direction of speed will be tangent to that circle. And that's a line. That's why we call it linear velocity. Whereas angular velocity is basically related to this arc expressed as radians, which remember is the arc based upon a unit one circle. As opposed to using degrees, that would be problematic. It's going to sweep out that much per time. That's kind of hard to measure mathematically. So that's why we use radians. Okay, so we'll have 3 examples. And I think I gave you guys 13 problems. All right, so this first problem, this object travels around a circle that has a radius of 4. All right, so we want to find the linear velocity and the angular velocity. Right, and it tells us something. It says we already are given that in 10 seconds, the amount of distance was 10 meters. And so that's linear velocity because that's distance per time. And so that's why I'm using the little v symbol here. Well, we can simplify that, right? That's really 1. So 1 meter per second is the linear velocity. Okay, now to get angular velocity, well, we got distance. How many revolutions would that be? And then once we get revolutions, we multiply by 2 pi to get radians. Okay, so 1 meter per second. So in 1 meter. So that means that would be 1 meter. And that happened in 1 second. All right, well, what would be the central angle in radians? All right, first we got to get revolutions. So I'm going to divide by 2 pi 4. All right, which would basically be 1 over 8 pi. And that's revs per second. So again, we had distance. We wanted revolutions, divide by circumference. So that's the portion expressed in revolutions. Right, so that's probably about 1/25th, roughly. All right, now we want radians per time because that's what angular velocity is. All right, so we got revolutions and we want radians, multiply 2 pi. So then now 2 pi times this would be rads per second. And when you simplify that, it's 1/4. So 1/4 radian in 1 second. Or you could say 1 radian in 4 seconds if you wanted. Okay, so we've got 2 more of these, and I'm trying to give you an example of each little variation, depending on what you're given and what you want to determine in the end. All right, so I'm going to erase that because I don't think I'm going to try to squeeze everything in one on the board. So is it okay if I can erase that? Anybody want to? Okay. All right, so now we got the next problem. Okay, so we got this motorcycle, and we're given the diameter this time of the tire, I think the back tire. And it tells us that it's going 25 miles per hour. All right, so right now we know the linear velocity. The linear velocity of the back tire is 25 miles per hour. We're also going to have to convert, because we're given diameter in inches units, which is also 2 feet. And we want to see what's the revolutions per minute, which would be a gauge on the motorbike, usually, you know, on the handlebars. And some cars also have this too. Okay. Now, a gauge is usually on the engine, not necessarily the back tire, the revolutions per minute. Let's go ahead and make this 2 feet. All right. That way we can go from miles to feet a lot quicker. Okay, so finding revolutions per minute, we got to convert this to units of feet and time units of minutes. All right, so I'm going to go ahead and set up the cross canceling. So we have miles per hour given to us. I'm going to go ahead and convert the miles to feet. So cross cancel the miles, convert the feet, and I'm going to go ahead and convert the hours to minutes. Okay, now if you like to put the numbers in with the units, I'd send you just use this as a model and then put the numbers below. Okay, so we've got 25 per 1. There's 5280 feet in 1 mile, and there's 60 minutes in an hour. Okay, and this is going to give us feet per minute. So we can use the diameter's unit of feet to determine how many revolutions that is, right? Because what we got is linear velocity. We got distance per time. Right now, we just converted it to feet per minute instead of miles per hour, but it's still linear velocity. It's still distance per time. Okay, and then this became 36 2/3. Now, again, you might be converting that to a decimal, but you try to avoid that. You know, even if you put this in your calculator, it's still accurate. So don't get in the habit of making that 0.66. Okay, and so now we want revolutions. Okay, now this is the diameter. And so with circumference, diameter times pi is what you can do. So 2 pi is our diameter times pi. Okay, so that's the circumference. So we divide this by 2 pi. Now, again, it looks like it's radians, but again, the only reason this is 2 pi is because the diameter is 2. It has nothing to do with 2 pi radians is 1 revolution. So I know that might be an issue. Okay, and so then we get revs per minute. All right. Oh wait, I did this a little differently. You know, actually, yeah, I converted to seconds up here for some dumb reason, but anyway, yeah. So I don't think that's the actual answer to that. Did anybody get that? Did anybody do that calculation? So I appreciate that, y'all. Everybody good? Anybody want to ask anything about that? All right. So now the last problem, we got this Ferris wheel. Okay, and I just made these numbers up, you know, so the Ferris wheel is probably bigger than like the one in Golden Gate Park that they were selling tickets to the people, and I think they stopped that. So we got 100 feet diameter. And we're told that this rotates a certain amount of revolutions per time while these people are sitting, going around in a circle, taking pictures and selfies, and having a good old time. So this rotates 10 revolutions in a minute. And that seems pretty fast, all right? So what's the angular velocity? What's the linear velocity? And then what is the speed in miles per hour that these people are experiencing as they're going around this Ferris wheel? Okay, well, we got revolutions per minute, 10 times per minute, this thing's going around. Right, so that's probably what, 1 every 6 seconds? It seems pretty fast. Now, if we want angular velocity, that means we want radians. So we have revolutions, we multiply 2 pi to get radians. So times this by 2 pi, you get 20 pi radians per minute. All right, now if we want a rate of speed, if we want linear velocity, we need to convert that to distance per time. And so let's convert it to feet per minute to get the linear velocity, and then let's convert that to miles per hour so that we can get a gauge on how fast this thing is going in terms of the speed we're familiar with because we all drive cars. Okay, so now, and let me just label this. This would be labeled with the little omega W funny symbol. Okay, so now we want to multiply the circumference because we want distance per time. And that would be times 100 pi. All right, so this is going to be 1,000 pi feet per minute. So every minute, that's the feet per minute, distance per time. So we would label this with the little V symbol. Okay, now converting to miles per hour is the same kind of unit cancellation structure, except now we're going from feet per minute to miles per hour instead of the other way around on the motorbike problem. Okay, so feet to minute. All right, let's go ahead and convert feet to miles. And then we'll convert the minutes to hours. Okay, and again, this is how I structure it, and then I just put the numbers underneath. You know, some people might have their preferences, but if your method works, that's what matters. But you just want to make sure your method works. Okay, so then we got the 1,000 pi over 1. 1 mile is 50 to 80 feet, and there's 60 minutes in an hour. When you multiply all that out, you should get, assuming I didn't make another mistake, 35.7 miles per hour. So that's how fast, given the initial conditions, 100 feet diameter, 10 revolutions per minute, that's how fast you're traveling. So if this is a bigger Ferris wheel, the Ferris wheel was bigger than 100 feet, right? That would mean that you would have a bigger number here, which means that would feel faster than 35.7. Right? Because more distance circumference means more distance per time that you'd be experiencing. Right? Where if this is a smaller Ferris wheel, then this would be a smaller number.